over the next couple of sessions, I'm going to be talking about situations where energy is put into the oscillating system. To start off with, I'm going to think about dampening. So this is the situation which is more akin to the real world. So in typical simple harmonic motion, it's kind of accepted that the simple harmonic motion will go on and on and on, and the total amount of energy will always be the same. As you may well be aware, that is a physics exam or physics world only situation. In the real world, we tend to lose energy. We tend to lose lots of energy. So instead of the idea of this spring going up and down forever, what happens is I recognise it slowly comes to a halt because of the dampening factors. Now these dampening factors are the fact that sometimes the force is not proportional to x, so we don't have that perfect situation to set up simple harmonic motion. More commonly, energy of the system decreases over time. Energy is lost to the system around us. And when that happens, we see that rather than the total energy always being the same, the total energy over time slowly reduces. It's dissipated to the environment all around. So that's the idea of dampening. Now we've got a whole range of, I guess, the amount of dampening that takes place. A slight dampening would mean, and that's kind of what we see here, I suppose, with the spring bouncing up and down, is that it's slowly the amplitude decays away, becoming less and less and less. That's one form of dampening. We can also get heavy dampening. Heavy dampening is so heavy, what happens that it slowly returns to its point, I guess, point of origin, and there's no real oscillation taking place. Then the third type of dampening would be known as critical dampening. This takes place where there's again no real oscillation, but what happens, it just goes to the middle point and then it just stops. There's no further oscillation there. So those are the three types of dampening that I need you to be aware of.